You are sitting in a park on a Tuesday afternoon when a woman walks over and sits beside you. She is white as snow, silver curly hair, eyes so pale they look almost colorless in the afternoon light. You are completely captivated. So, you ask her name. She says Abarash. She tells you she is from a tribe in Sub-Saharan Africa. And in that moment, something shifts in your mind because you realize you are looking at a black woman with albinism. You ask for her number. She takes your phone and types with her left hand. You notice her eyes more closely and realize something strange. One eye is pale blue. The other is a shade of brown you have never seen before. A brown with colors layered inside it that you cannot name. You go on dates. She is brilliant. She quotes conversations from years ago word for word. She remembers the exact sky of every important day. You have never met anyone like her. You fall in love. She becomes your girlfriend, and then your alarm goes off. You lie there with your heart racing, the dream already fading. And you ask yourself, does a person like that actually exist? Statistically, yes, but that raises a question more interesting than the dream. Out of 8 billion people alive on this planet right now, what would the rarest possible human being actually look like? To answer that, we need to build this person, trait by trait. And with each trait, we will calculate the probability of that combination existing. By the end, you will have a number so large it will make the universe feel small. Let us start with where our person comes from. There are roughly 7,000 distinct ethnic groups on Earth. Most of humanity is concentrated in a small number of enormous populations. The Han Chinese alone account for about 18% of the global population. More than 1.4 billion people from a single ethnic group. At the other end of that scale, the Sentinelese of the Andaman Islands number between 50 and 400 people. The Kawahiva of the Brazilian Amazon are believed to be fewer than 30 individuals. The Spinifex people of Australia numbered around 200 at their last count. For the rarest human, we place their origin in one of these groups. 500 people against 8 billion. That is 1 in 16 million. Our person now has a 0.0000006% chance of existing. Now we give them albinism. Albinism is caused by mutations in the genes responsible for melanin as the pigment that determines the color of skin, hair, and eyes. In a person with complete albinism, this production is either severely reduced or entirely absent. The result is near white skin, silver hair, and eyes ranging from pale blue to gray to pale pink, depending on how light interacts with the unpigmented iris. Globally, albinism occurs in approximately 1 in 20,000 people. Combined with our ethnic probability, our person now has a 1 in 320 billion chance of existing. 320 billion. We are barely getting started. Now the eyes. Not just the color, the split. Complete heterochromia is a condition in which a person has 2 completely different colored eyes. 1 blue, 1 brown, 1 green, 1 hazel. Present from birth. Caused by differences in melanin distribution between the 2 irises. Harmless and extraordinarily rare. The probability is approximately 1 in 1,667 people. Our rarest human is left-handed. This sounds common. It is not. About 10% of the global population is naturally left-handed, but in many traditional communities, children are pressured to use their right hand, meaning the true frequency may be even lower in isolated ethnic groups. We keep it at 1 in 10. We pause here to count. Ethnic origin, albinism, heterochromia, left-handedness. Combined probability, 1 in 5.33 quadrillion. A quadrillion is a 1 followed by 15 zeros. There are not 5 quadrillion grains of sand on Earth. There are approximately 7.5 quintillion, which means if you took every grain of sand on every beach and desert on the planet, you would need to find our person among all of them and still have room left over, and we are not finished. Our person sees the world differently from everyone around them. Literally. Most humans see color through 3 types of cone cells in the retina, roughly sensitive to blue, green, and red wavelengths. The brain combines these signals to produce the 1 million or so colors visible to typical human vision. But some people have a 4th type of cone cell, sensitive to wavelengths between red and green. This is called tetrachromacy. A tetrachromat can potentially distinguish up to 100 million colors, shades that are completely invisible to the rest of us, colors that do not even have names, because no one has ever needed to name them. Tetrachromacy is almost exclusively found in women, linked to the X chromosome. About 12% of women carry the relevant mutation, but only a small fraction develop functional tetrachromacy. Researchers estimate it occurs in roughly 1 in 40,000 women, or 1 in 80,000 people overall. Our person also remembers everything. Highly superior autobiographical memory, sometimes called hyperthymesia, is the ability to recall nearly every day of one's life in extraordinary detail. Not just major events, ordinary Tuesdays, specific conversations from a decade ago, the exact color of a sky on an unremarkable afternoon. The condition was first formally identified in 2006 when neuroscientist James McGaugh studied a woman named Jill Price, who described her memory as an involuntary, continuous replay of her entire life. She could not forget anything, even when she wanted to. Fewer than 100 confirmed cases exist worldwide. Even generous estimates, including undiagnosed individuals, place the total at a few hundred people globally. We use 508 billion, 1 in 16 million. Now we stop and look at what we have built. A person from an ethnic group of 500, with albinism, with complete heterochromia, left-handed, tetrachromat, and a memory that records everything. The combined probability of this person existing is 1 in 6.83 septillion. Let that land for a moment. A septillion is a 1 followed by 24 zeros. The total number of stars in the observable universe is estimated at 1 septillion, a 1 with 24 zeros. To reach the number we just calculated, you would need to count every star in the observable universe 6 times over. You would need 910,000 planet Earths, covered entirely in sand, to even approach the number of grains required to represent this probability. And we have not even started on blood type, on rare genetic mutations, on the thousands of other traits that make a human being who they are. The point is not the rarest person. The point is what this calculation reveals about every person. You were not born into a universe that was waiting for you. You were born into a universe that was indifferent to you. And yet here you are, the product of a chain of coincidences and combinations so specific and so improbable that if any single link had broken, anywhere across thousands of years of human history, you would not exist. Not someone like you. You, exactly. The probability of you. Your specific combination of genes, your memories, your particular way of seeing, is not 1 in a septillion. It is effectively 0. And yet you are here, reading this, having this exact thought at this exact moment. Now go back to the beginning of this video. To the woman in the park with silver hair and 2 different colored eyes, and a memory that never lets anything go, she was dreaming about you too.